We often look at the starry sky wondering, are we alone in the universe? And when we do, we tend to imagine distant galaxies. However, extraterrestrial life may be much closer. Imagine a space object with an ocean twice as big as here on Earth that is 100 kilometers deep. It's covered with a 20-kilometer thick layer of ice, and 200-kilometer geysers sometimes erupt from under it. It is one of the most promising objects for extraterrestrial life search. You will be surprised, but it lies in the solar system. This is Jupiter's moon, Europa. How can life emerge in such conditions? How can we assume that there might be life there? And how can liquid water even exist so far from the sun? What secrets does Europa hide? To this day, 95 satellites of Jupiter have been discovered. However, scientists are most interested in the 4 largest ones, which were discovered by Galileo Galilei as far back as January of 1610. They were named the Medicean stars, in honor of the famous family, one whose members sponsored Galileo's astronomical research. However, the satellites have been given the name Io, Europa, Ganymede, and Callisto by the German astronomer Simon Marius, who claimed to have discovered them a week before Galileo. Researchers believe that Jupiter has accumulated a large amount of thermal energy due to gravitational compression during its formation, and is now giving off more heat than it receives from the sun. Therefore, the gas giant and everything around it resembles a miniature solar system. It's worth mentioning that the chances of finding signs of life on Jupiter are close to zero due to the lack of a solid surface, high temperatures in the planet's internal layers, and extreme pressure. The latter reaches 80 million bars in the center of Jupiter, while atmospheric pressure on Earth is only 1 bar. Now, the second farthest satellite in the Galilean quartet, Europa, is considered one of the primary candidates where we could discover biological life in the solar system. Europa is close to the Moon in terms of size. Its diameter is about 3,122 kilometers, compared to the Moon's 3,476 kilometers. Europa is 670,900 kilometers away from Jupiter and orbits it in 3.5 Earth days. To compare, the distance from the Moon to Earth is 348,400 kilometers. Europa's mass is equivalent to 0.6 of the Moon's mass. Moreover, Europa is predominantly made up of silicate rocks, which makes it similar to terrestrial planets. The temperature on the surface near the equator is around minus 163 degrees Celsius, minus 325.5 degrees Fahrenheit, while it can drop to minus 223 degrees Celsius, minus 433.4 degrees Fahrenheit at the poles. The surface of Europa is made up of ice and is one of the smoothest in the solar system. Europa's entire surface is densely covered with intersecting lines. These are fractures and cracks in its icy crust. Some of them almost entirely encircle Europa. Their scale is breathtaking. In some places, the fissure system resembles the landscape of the Arctic ice cover on Earth. The elevations are mainly represented by terraces, elongated hills no higher than 200 to 300 meters, 650 to 1,000 feet. There are also extensive paired ridges. Most likely, they are formed as a result of ice accumulation along the edges of opening and closing cracks. The atmosphere of Europa is very thin, and it contains molecular oxygen. The pressure on the surface of Europa doesn't exceed 1 micropascal, which is 10 to the power of 12 times lower than atmospheric pressure on Earth. Moreover, Europa lies in Jupiter's strongest radiation belt. A person can't survive even a day under such radiation. it's safe to say that these are not the most favorable conditions for the emergence of life. However, if you examine the structures of Europa, some questions are bound to arise. There is a small metallic core in the center of the moon, followed by rock, most likely silicates, which allows the satellite to be classified as an object of the terrestrial group. It is logical to assume that the soil is followed by solid ice. However, this is a mistaken view, as the ice crust is 10 to 30 kilometers thick. So what is between the crust and the ground? A huge mass of salty liquid water. According to scientists, the hidden European Ocean can reach up to 100 kilometers, 62 miles deep. Do you remember the parameters of the deepest point on Earth, the Mariana Trench? It is about 11 kilometers, or about 7 miles deep. At the same time, the average depth of the Earth's entire world ocean is 4 kilometers, or 2.5 miles. Based on calculations, the hidden European Ocean contains almost twice as much water as the entire world ocean on Earth. But how did they find out it exists if no one has seen it? Initially, assumptions about the existence of subglacial water arose because the surface looked quite young. There are too few craters on the satellite, and the surface is relatively clean. Based on these signs, in cosmic terms, Europa's crust formed only 20 to 100 million years ago. Therefore, the crust may have formed during this period, locking up the ocean, or water from the depths regularly reaches the surface and freezes up, rejuvenating the landscape. But let's be honest, it's not enough to support the claim about liquid water on a satellite that is about 780 million kilometers away from the Sun. Spacecraft studying Jupiter and Europa have played a major role in the emergence of the subglacial ocean hypothesis. For the first time, Europa was photographed by the Pioneer 10 and 11 spacecraft in 1973 and 1974. 5 years later, the first and second Voyagers not only took pictures, but also conducted some research. It was then that scientists started to propose the existence of a liquid ocean. In 1994, molecular oxygen was detected in Europa's atmosphere using the Hubble telescope. The Galileo automated probe that studied Jupiter from 1995 to 2003 made the greatest contribution to unraveling the mystery of Europa. However, its orbit repeatedly intersected with Europa's, allowing the probe to approach the Moon as close as 201 kilometers away. But most importantly, Galileo discovered that Europa has a weak magnetic moment, caused by changes in the external magnetic field. The existence of a variable magnetic field requires a conductor of electricity. As we know, soil and ice are not conductive, but salty water is an excellent conductor of electricity. Moreover, the analysis of the data obtained from Galileo led to another discovery. In the past, the satellite's crust shifted by 80 degrees relative to its core, which would be impossible without a liquid layer. But perhaps the most important and spectacular evidence of the presence of liquid water beneath the ice sheet is geysers. Talks about water vapor emission began in 2012. Studying images taken by the Hubble telescope at different times, scientists suggested the presence of geysers. In 2016, Hubble recorded water plumes of up to 200 kilometers erupting from the depths of Europa. Take a look at these stunning images of geysers. Are you still doubting that this is water? So there is virtually no doubt about the presence of liquid water on Europa. The volumes of emissions and the source of geysers remain unknown. Either they erupt directly from under Europa's subglacial ocean, or they are formed in giant subglacial lakes that are isolated from the primary ocean. In general, there's almost no doubt that there is water. but its source is still unclear, especially given that the temperature on the surface is lower than minus 200 degrees Celsius, and there is an iron core inside. As we mentioned, scientists claim that currently Jupiter gives off more heat than it absorbs. However, this energy would hardly be enough to melt the ice, especially from within. Therefore, the energy must come from within the planet. Now this must be it: deformation, or internal friction. Jupiter exerts a strong gravitational influence on Europa, causing powerful tidal waves in its hidden ocean. As a result, the moon's crust expands and then contracts. Fissures all over the surface appeared as the result of Europa's crust stretching and cracking. Based on the first look at these fractures, heated ice emerged from below. As you know, any deformation heats up the body. Remember making plasticine crafts in your childhood? You would take a cold, hard piece out of the box and start kneading it in your hands. And after a while, it would become warm and soft. But this wasn't due to the warmth of your hands, but because of internal friction. The same thing happens when we try to break a wire, sharply bending it in different directions. Eventually, it breaks, and the metal near the fracture becomes hot. And now imagine a 100-kilometer ocean whose waves regularly press against the icy crust, converting kinetic energy into a thermal one. Presumably, the heat generated this way is sufficient to keep the water in a liquid state. The presence of water certainly doesn't prove the existence of life. However, Europa is still considered one of the most promising places to look for life in the solar system. Biological life requires a multitude of factors to emerge and develop. Scientists identify three main factors that are needed to consider an object potentially livable: liquid water, energy source, a certain set of chemical elements. Europa seems to have all of these. We certainly understand that there cannot be any life on the surface, but what about under the icy crust? There may be acceptable conditions for life there. The icy shell reliably protects the oceans from meteorites and radiation, being also an excellent insulator. Heat can remain for a long time under such an icy blanket. But what about oxygen, you may ask? That is certainly an interesting question. First, we don't know the exact composition of the subglacial liquid. Let's call it that for now. Secondly, as we know, molecular oxygen is present on Europa's surface. How did it appear there? Maybe it was ejected from the depths by geyser flows. Anyway, the absence of oxygen doesn't prevent biological life from developing. Life on Earth originated in an anaerobic form. Eventually, algae filled the world ocean, producing oxygen. Algae can even be different colors on Earth, including red and brown. So maybe the red streaks on the cracks of Europa aren't the result of oxidation processes, but algae ejected by geysers or lifted from the depths as a result of ice sheet migration. As you know, life can take on very different forms. Even on Earth, scientists regularly discover new species. One of the most impressive discoveries in this field is the presence of life near black smokers. Active hydrothermal vents on the mid-ocean ridges on the ocean floor. Have you heard of such a wonder in terrestrial oceans? High mineralized hot water under the pressure of hundreds of atmospheres is released into the oceans from these vents. They are tubular formations that can be tens of meters high. Black smokers are also known as oases of life in the deep aphotic zones of the ocean, which has no light exposure. This zone usually lies over 200 meters deep and up to the lowest points of the ocean, about 11 kilometers deep. It is the habitat of some unique biological communities, forming independent ecosystems. Thus, the deepest parts of the biosphere, reaching depths of 2,500 meters or more, are associated with them. Studies published in 2016 suggest that the last universal common ancestor, Luca, of all living organisms, which existed approximately 3.8 billion years ago, may have been a resident of hydrothermal vents. What does distant Europa have to do with it? The one thing is, in 2017, indirect evidence led scientists from the Cassini mission team working on the Saturn system to hypothesize that Saturn's moon, Enceladus, where there is also likely to be liquid salty water, may have black smokers capable of supporting primitive microbial life. It's quite plausible that there are oases of life on Europa with conditions similar to those on Enceladus. We can't yet make any definitive claims about life on Europa. To find out, we would not only need to visit this Galilean moon, which is already a non-trivial task, but also drill at least 10 kilometers into the perennial ice. It's still unclear how to do this. We could melt the ice rather than drill, but where to get so much energy? However, there might be another way after all. Surface cracks. Some cracks may as well be hundreds of meters or even several kilometers deep. Meanwhile, humanity is only attempting to travel to Mars, and landing on Europa is still just a dream, even when it comes to exploration probes. But there's also good news. The JUICE spacecraft, designed to explore the Jupiter system, has arrived at the launch site. The Ariane 5 rocket will send the 6,200 kilogram spacecraft to the Jupiter system in April 2023. The JUICE will only reach the orbit of this planet in July 2031, after a series of gravitational maneuvers in the inner solar system. For 3.5 years, the JUICE will be flying past Ganymede, Europa, and Callisto. In December 2034, the spacecraft will remain in orbit around Ganymede and will more thoroughly explore the largest natural satellite in the solar system. Will the mission bring a sensation? Will new facts be discovered, getting us closer to unraveling the mysteries of the icy ball? For now, there's nothing left but to keep stargazing and asking ourselves again, are we really alone in this infinite universe?